Well, hey, it's your old pal, Mr. Cook. Let's do these last two little graphs. Graph each system of inequalities. Are the systems bounded or unbounded? So bounded means that it'll be enclosed within like the shape. Okay, like if I had let's see here. Well, we have a circle in number 12. Like if I had a circle, right, and then there'll be a line through it. So like a line like that. If the shaded region, the common shaded region, is within the two equations, like the two functions, we call it bounded. However, if it's like outside of the equation, so like if it's like that, and we're shading like out here, like so where it goes on and on and on forever, right? That's what we call unbounded because it's not like bounded above by something. Okay, so when it's bounded, it's like enclosed. Think of it as being like enclosed, and then unbounded means that it's like not enclosed; it's completely open. And it goes on and on and on forever. So think like goes on infinitely or something. Okay. All right. Oh, I just realized I don't have a lot of space to write. Okay, so let's see here. We've got a linear equation here. So I always like take my inequalities. I treat them like they're equalities, like they have equal signs on them, and that's like when I'm graphing them out. So I would just think, okay, how do I graph out this equation here? Okay, so I graph out 4x plus 5y. I'd probably just like do some check the intercepts on it. So like if I plug in 0 for x, then my y value would have to be equal to 4, and then if I plugged in 0 for y, my x value would have to be equal to 5, so 5, 0. So if I graph those two coordinates, 5, 0, and 0, 4, that gives me, my slope down 4 over 5, so negative 4/5. 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. So here's my line. And then now here's the deal though, okay? It's not exactly a line. It's like an inequality. And if you have like a less than symbol or just a greater than symbol, right? It's a dotted line. It'll look like this when you graph it out because it doesn't like include those numbers. It just has like everything up to that point, up to that line, but not including it. Okay, so there's my little line there. 4x. Oops. Gosh, sorry. Let's see here. 4x plus 5y less than 20. And then I have, let's see, what's that other shape? That other shape, it looks like a parabola. So I think of it as like y equals x minus 3 squared. So what does that thing look like? That goes through, 3, 0. That's the vertex. And then it goes up. So let's see how that one looks. So it's like that. And then over 2, up 4, 1, 2, 3, 4. And reflected. And then over 3, 1, 2, 3. And then up 9. And reflected. Okay, so yeah, here's how my parabola looks. And since it has like an equal sign on it, it's going to be a solid line. So I can just draw directly through the points. Here's my parabola right there. Lovely. Okay, so now let's like figure out where this thing is going to be shaded overall. Let's use some colors to kind of illustrate this. All right, so generally speaking, what I like to do is when I've got a system of equations or a system of inequalities, I like to just use test points to see where the thing is going to be graphing. I know like some people like to say like, oh, if it's less than or greater than, it's just shade above or shade below, right, left, that kind of stuff. I like to just use a test coordinate because I think that's the easiest thing in the world to use. So like for my linear equation, what I would do is just pick a coordinate that's either on the, above the dotted line or below it. So like either up here somewhere, like above it or below it, and I'd see if the inequality works. My favorite coordinate to use in that case is the origin, if it's available. So I'm going to use the origin as a test point, and I'm going to see if that makes the inequality true. So I'm going to plug in 0 for x and 0 for y and see if it works. So 4 times 0 and 5 times 0. That gives me 0. And is 0 less than 20? The answer is yes, it is. So since this coordinate works for this inequality, this dotted line right over here, that means that every single coordinate that is like below that line is also going to work. So if I picked another random coordinate, like, 1 over here, for example, that should also work in the inequality. So that's like where I'd shade. I'd shade below the line. Okay, and then the next thing I'm going to test out is my parabola. And I do the same thing. I'd maybe check the origin if it's available. The only time that you can't use the origin is if it's on one of the lines, or the parabolas or whatever, like directly on the line. Then you can't use it because it's inconclusive. So I'm going to try the origin with this inequality here. So I plug in 0 for y and 0 for x, and I'd see if the inequality is true. If it is true, then I would shade everywhere outside of the parabola, like out here somewhere, like I'd just be shading outside of it. If it does not work, then I'm only shading inside the parabola. Okay, so like just inside the parabola. So let's see if this works. So 0 less than or equal to 0 minus 3 squared. Well, that's 3 squared, which is 9, so 9. And yes, that is a true inequality. So that means that the origin also works. So I'm shading outside of the parabola. So what is the common shaded region? It's the shaded region that is, oh, you know what? I made a small little mistake. Good thing I caught this. I was just looking over randomly over at the inequality. I wrote in the wrong direction over here. Darn it. Sorry about that. If that was a little bit confusing. I bet you're probably sitting there going like, Mr. Cook, you dummy, you made a mistake. So actually, this inequality is not true. So that means we actually got a shade like above that line. I'm so sorry about that. So for that particular inequality, we're shading above the line. So this is the common shaded region. It's like above the red line, and then below like outside the parabola. So here is the common shaded region. So let's see what that looks like. It's like above the line, but outside the parabola. So it's like all the stuff up here, right? But it's outside of the parabola. So it's like not inside the parabola. So like out here, and then all the way like out to the parabola, and then above the line. So it's up here. It's like all this blue shaded area right over here, okay? So there we go. And is this thing bounded or unbounded? Well, this is going to keep going like off the page forever, like it's just going to follow the parabola essentially forever. So what we call that is unbounded. So this thing is definitely unbounded because it goes on and on and on forever. Okay, number 12. So for number 12, we do the same thing. Let's hope to not make any mistakes on this one, right? So it looks like this top equation is going to be a circle, x plus 2 squared plus y minus 3 squared equals 36. So I'm going to say that that's a circle with a center at -2, 3, and a radius equal to 6, right? Because I just used the whole thing that we learned back in the conics section just a little while ago, right? You know it. Yes, you do. You have it memorized, right? Okay, so my center is at -2, 3, so to the left 2, up 3, there you go. Radius of 6, so we go out 6 in every direction. Left, up, let's see, 3, so that'd be 9. To the right, so that'd be up to 4. And then down, so 3 and another 3 puts us at -3. And then try your best to make that look like a circle. Doesn't look like it's going to be perfect. Let me make sure that that's all 6 in every direction. 1, 2, 3, 6, and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, it is. Okay, it's just going to look a little funky. And I'm lucky. I wasn't really paying much attention, but I probably should have also checked to see if this was going to be like a dotted line or a solid line, and it's a solid line. But always make sure that you check. Geez, this one looks more like a football than anything else. Whatever, did my best. So there we go. There's that thing, and then looks like this one's going to be a line. I'm just going to get the x value by itself. So x is less than, and then it'd be y minus 2. And then if I add the 2 over to the other side, this is going to make the inequality a lot easier to work with. X plus 2 less than y. And here's why. That's a really easy linear equation to draw up, right? X plus 2 equals y. So this is going to be a dotted line, so you got to remember that. And let's see, the y-intercept starts at 2, and then the slope is 1. So dotted line, and it just goes up and over by 1 each time. I'm going to say it looks like that. Okay, there we go. There's our line. There's our circle. Let's get to work. Let's figure out how this thing is going to look shaded. All right. So let's do the circle in red. Okay, so the red. The easiest point to pick on a circle is either the origin if it's available, but that's always simple. But I like to use like the center of the circle because it does something pretty cool. It's just going to be zeros basically. So if you plug in -2 for x, you get -2 plus 2, which is 0. So 0 squared is 0. And then if you plug in 3 for y, 3 minus 3 is 0. So you get 0 there too. So basically, you're just asking the question, if you plug in the center, is 0 less than 36? And yes, it is. So the inequality works. So that means that we're going to be graphing inside the circle. Now we just got to decide if we're going to be shading above the dotted line or below it. So let's see that one. So for this one, let's pick the origin, I guess, or you could use the center again if you want, whatever. I'd probably just use the origin. 0 minus 0 less than -2 is 0 less than -2. I'd say no. So that means that we're not shading like below the line because that's where the origin is. We're shading above it. So we're going to shade like above the line and inside the circle. So here's how it looks. Ready? It's going to be like all this stuff here inside the circle, but only the stuff that's above the line. So it like kind of stops there at the line. And is this thing bounded? You betcha, because it's completely like enclosed in the circle and kept at bound with that dotted line right there. Okay, so this is a bounded inequality. Okay, that's it. That was our colorful finale. I hope you enjoyed watching the videos. I'll make an extra review video as well and post that in a second. Okay, have a nice day. See you later.